Hi, this is Dr. Graves. This is a quick video tutorial that will assist students in my field course and perhaps in the forensic geography course and perhaps the statistics course understand how one might use Anova, a statistical test, to see if differences between locations or observations taken in various locations are statistically different enough from each other to call them different, or if they're really not all that different. So on a field trip, we collected 2 sets of data using our quick capture app. One was the fear and disorder scale, and if I zoom in here, you can see these are the observations made by students. The darker the green, the higher the building displayed fear. We also had a disorder scale that students collected, and the darker red colored dots on the map indicate a higher level of disorder, and the yellow indicates high order of a high degree of orderliness. So these points have all record the student's name that collected the data, and through a simple join command I was able to join the zone number to each of the observations. I then exported that out to a DBF file, and this is the data that you will be presented with and made available to you. And what you are going to ask yourself is, are the fear scores and the disorder scores different sufficiently by zone? And those zones are the neighborhoods on the map, zone 1, 2, 3, 4. In the Excel, you can see that the median income by zone 4 has a median income of $95,000 and zone 1 at $110,000. And these crime rates, which we're not going to address in this video, are also significantly different. So our question is, are the fear levels and the disorder levels that you have recorded, do they differ significantly by neighborhood? So how do we do this? First thing we're going to do is just click somewhere in this file. All students will have the file, and then click on the Insert tab and click Pivot Table. If you've clicked inside the pivot table, the software should automatically recognize the entire table. So, and you may allow it to establish a new worksheet. So click OK. And here's your blank pivot table that's appeared on, well, mine says sheet 3, and I'm going to rename it to pivot table. And what we want to do is to, let's just do fear first. Click and drag fear to the values box in the lower right hand corner. And we don't need sum. I think the better thing to do is average, even though it's going to be the same. So I right clicked on the sum of fear, brought up the value field settings, and clicked OK. So, or it wasn't a right click, it was just a down arrow click, value field settings, average. That's what you want to do. So this is the average of the entire group, all the observations. And then we want to grab zone by clicking on it and dragging it to columns. So these are the averages by columns, and essentially what we want to ask are, is this average the same as this and this and this? Do they function, or should they function as if they are a single region, or are they distinct or is at least one of them distinct from the other three? And we see that this one is below 2, so, and this one's nearly 2.5 on the fear scale, so higher. And the question is, are any of them really all that different from the group as a whole? So the next step is to grab OID, which is just an identification number, and put it here. And then we get this long list of observations, all individual ones. And then here we want to, in the pivot table tools, should come up, and let's just grab a slicer. So click on Insert Slicer, and a slicer is a filter, and select Name, and click OK. Now this is the name of all the students that are in this course this semester, and my observations are here under Gravy. So I'm going to select Gravy. You select your name from this class. And at this point, we're really ready for an analysis. The difficult part is establishing whether or not you have the analysis tools. I'm going to click on Data. Over in the upper right hand corner on this top toolbar, you should have Data Analysis. If you've used Excel for data analysis in the past, you will have that. If you do not see that, click on File, click on Options, click on Add-ins, and then scroll to the bottom, and you want to click Go to the left or the right of Manage Excel Add-ins. Click Go, and then just make sure that Analysis Tool Pack is selected by checking on it. Click OK, and Data Analysis should appear in your data toolbar at the top. If it doesn't, please contact me, your instructor. So now that we have that, click Data Analysis, click Anova Single Factor, click OK. If you want to understand how this works, click Help, and there will be a help window that will appear, and it will give you more specific instructions about what's going on here. We're going to do the Anova Single Factor. We only have one factor at this point, and it's fear. And we have to tell the software which data that we want to analyze, and it is the data from Region 1, Region 3, Region 4, and Region 6. And we're just going to highlight all the way down until we get to that blue bar there that has the grand totals. We don't want to include those. So we've highlighted that. Our data is grouped by columns. They're up and down. And we do have labels in the first row, and those are just these numbers here indicating the zone. Zone 1, Zone 3, Zone 4, and Zone 6. And generally this alpha data here is set at 0.05, which means that we will have at least a confidence interval, or confidence in our calculations at 95%, that we're 95% sure. And so then here in the output range, just click somewhere to the right of the rest of your information. We can move the slicer off when we want to. I'm going to click here. I'll just click here in cell M1 and click OK. Grab the slicer and move it off to the side. And here we have our results, or my results, for Anova Single Factor. And what we have here is an analysis of our data. These are the averages that we saw already, and they, if we scroll down to the bottom, we will see that they match perfectly or exactly our 4 average values that we had before. But it also has calculated the variance, which means how much internal variance around the average there is. Are they all clustered around the average, or are they spread out? And you see that for me, that in group 1 at the top, the average was 1.88, and then the variance is smaller. And then as you get further down the hill, the average was 2.214, but the variance is bigger. So what this test does is it looks at the amount of variation between the groups. It compares the 4 groups variance between them against the internal variation within each group. The idea is if there's more internal variation within the group than there are between the groups, then you probably don't have 4 groups. You have actually just sort of one group. This has a lot of value for a number of applications in geography. Are these states different? Are these counties different? Are these neighborhoods actually different in any way? And that's essentially what it does. And so these two values here are divided by each other to get this value. And when these are relatively similar, then this value, the F value here, gets lower. If the F value exceeds the F critical value, or the critical F value, which is in this case 2.75, then we would say that these groups are different. This is a rejection of the null hypothesis. The null hypothesis simply states, nothing going on here. That these are all the same. If we reject the null hypothesis, we say something is different. But in this case, for my observations, I find that the F value is 1.54, and that is smaller than the F critical value by a substantial amount. And so there isn't much variation between these groups. The p-value is another indicator of the confidence in your ability to reject the F. As this value in F, or reject the null, as this value approaches the critical value, the p-value will trend towards 0.05, and that would be, you would say that you were 95% confident that these 4 groups are not functioning as one. But in this case, they're actually so similar that you could just call them really one group. And that is how to calculate Anova and understand the readout values. Your task is likely for this class is to reproduce what I've done here with the fear value, and then change this around and change the fear out and do it once again for disorder. Don't do it for gravy, do it for whomever you are. I'll make sure that that is set to average as well. And then run this Anova test again. Questions? Certainly get in touch with me. That concludes this video tutorial.